Hello, Pearl folks. This week is regular expression. Go ahead and read everything you can, and we have perfectly good coverage in both the CGI 101 and the online book. But definitely go over the class notes. Those should also be somewhat educational. The exercise is called Catch Bad User. This is an exercise in reading log files, which is a very important job of Perl. And this is going to be 2 weeks. The first week, we're going to look at these class notes, and the second week, we have another set of class notes to review and basically review regular expressions. Okay, so we're going to look at the class notes for this week. First of all, there's a match operator, which is regularly followed by two forward slashes, in between which we're going to place an expression, a regular expression. Let's start off with a string that contains this sentence. It is winter and there is snow on the roof. We're going to have another string called pattern for and. So in other words, we're going to be using this this variable to look for the word and somewhere in this sentence. Okay, we begin with print. We're going to use print found snow if the string, and here's the new operator that we're learning with regular expressions. It's called the binding operator. Another way to read this is, does string contain snow? This is definitely a way I look at it. If string contains, and then you have your match operator, and here's the regular expression, which happens to be simply text in this case, snow. So it's going to look, this is going to turn into a regular expression and it's going to look into strings. It is going to go by character, and first it's going to find an S. Then it has to match an N right after the S, and in case, and this is the case right here. Then it's going to look for an O directly following the N, and finally a W directly following the O. And as soon as it comes up with this match, then it quits. It doesn't go any further in a sentence to keep looking. So there's our first introduction to this concept of regular expressions. We can also use scalar variables within the regular expression. Interestingly, the $sign does have meaning, but Perl will override that if it finds a legal variable. Number 2, note that the forward slashes separator characters can be substituted by another as long as one closes the other and use the M operator. You also have to do that. For instance, we can say print found pattern there, meaning A and D space there, correct? If string, now we use the match operator, and we can use a period. If there happen to be usually a lot of forward slashes in your match expression, then you might want to use a period instead, or anything else, any other thing that you want. This will not work just by itself. So, by the way, let's go ahead and run this. And we found snow, and we found the pattern and. Very good. Number 3, finding characters which have special meaning with regex. For instance, a period, as we'll learn shortly, has a special meaning in regular expression. Therefore, if you're looking for a period, just simply protect it as we have done in the past. Next, shortcut example. A shortcut, excuse me. Not here, nor here. Finally found. and we're using this in the for each, of course. So this is a list, right? A list of 3 different items here coming through, and we're going to print. What do we print? Well, the $_ if what the $_ and use the equal enya symbols, and you just use your forward slashes for the regular expressions by itself, and we're going to try to match found, which of course is only going to be found right here. I think we can just go on without running so far. Substitution, something very similar, but this time we get 3 forward slashes because the second set here will be what we want the regular expression to be substituted by. For instance, you can say S, find the lowercase abc, and replace that by capital ABC. The string example here, it says this world is our world, and that string contain world. If so, replace it by planet. Also, we're going to take that same string, and by the way, the substitution is going to make the changes in the string. So substitute our, which is going to be found right here, and we're going to replace that by there. Notice that there's 2 instances of world, so you would expect this sentence right here, this expression, to only do the first one. Print string after planet substitution, and we're going to see what that looks like. And here we go. String after planet substitution. This planet is their world. Global modifier. So in order to fix this problem, we can use G at the end of the regular expression here. This stands for global, and that will force Perl to keep going and not stop after the first match. So here we go, and also notice that, what do we have here? This is string. Does it contain world? If so, change it to planet and do it globally. And now we have a second assignment on the left here for hits, and that simply means the result of this expression will be the number of finds. So we're going to print the string after the G substitution to see how that looks like, and we're going to print this variable hits. Number of hits is 2, and now we definitely change planet in both cases. Number 7, special characters and character classes. Well, now we learn the actual regular expression reserved words. D with a backward slash in front will match any digit, meaning one digit, okay? Capital D is a non-digit. Lowercase w is an alphanumeric character or underscore. So basically, any characters that are usually used in usernames and passwords, those types of characters that can be recognized with a lowercase w. Non-word, anything else is a capital W. Space and a non-space, and the dot matches anything except for a return character. Okay, that's the period. And then we're going to use these square brackets, which give you an or situation between characters, and this set of parentheses saves the information into special variables, $1, $2, $3, and so forth. Every time a regular expression encounters a set of parentheses, it will save whatever it found, if anything, into these variables, and we'll see how that works shortly. This string now contains, this one has a 2, so here we're introducing the digit, and we're going to ask, does the string contain one digit, right? One digit. And we're also going to surround this with parentheses, meaning that this value, if it finds it, we'll leave it in a special variable $1 because it's the first one. There's only one set of parentheses here, so it's going to be stored in $1. The next example, this string has 2 digits, and now note that we're going to look for one digit. Then we're going to expect a space, and yes, we have a space here and only one. And following the space directly, our regular expression is asking to find one more digit, and it should find it, right? Because we have one more digit after the space, and this time we have this first find surrounded by parentheses, and we have a second match with parentheses, so we expect those results to be stored in $1 and $2, and that is what we're going to print. And sure enough, found variable 1 was 2, and then it found 2 and 5, which is $2. Number 8. We have in this we're using the same string, right? Our last string was this one has 2 and 5. Here we're going to use the brackets, and instead of using the digit, we could also ask for either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now inside those brackets, we're allowed only one character at a time here. You can also use this, or the two dots, of course. And what is it going to look? It's going to simply, what are we asking for here? We're asking to find one digit. Okay, inside these brackets are all the allowed characters, but this only one, it turns out to be one. This is only one of these characters will be matched. So here we're only going to find one, because don't forget we also have the set of parentheses around here. Therefore, the result will be stored in $1. And there it is. And we did this twice. Number 9. Alteration. The pipe symbol. Okay, so now we can use the pipe. We've learned that pipe is a reserved word in regular expression. And the string is hello there buddy. And we're going to ask, does the string contain? Now notice that we have two sets of parentheses here. This is for the entire match. And then we have a second set of parentheses just for this or situation here. So we're looking for either hello or hi. Okay, we cannot use the square brackets here because we have an entire word here. We have several characters. Remember the brackets are only for single characters. If we're going to be using strings, well, then we can use the pipe symbol. So this will effectively look for either hello or hi, and it's going to find hello, and is going to leave this find in this set of parentheses, which by the way will be 1 or 2. So just have to know that these $ numbered variables refer to the parentheses as in sequence as they are found. So the first one is going to be $1, which is the entire string here, the entire regular expression. The second one is going to be stored in $2. Note how the parenthesis works with $1 to a set of variables. Okay, let's see the result. So what are we expecting here? Hello, from this first, well, actually the first one is, it should give us the entire thing. Hello space, because this is a space. We didn't use a slash s, but this still counts as a space in regular expression, and then followed by the THERE, and it will go ahead and match all that because we have hello space there. So that will be a match. So hello there is the entire regular expression, and then the second set of parentheses was just matching hello or hi. So there we go. Same string, hello there buddy, with this time what is happening here? Does it contain hello or hi, space there, and space buddy? Well, in this case, yes. We're gonna end up with three sets of parentheses, right? This is gonna go in $1. This will go in $2, and this will go in $3. Hello there, buddy is the entire thing. Hello and buddy. Now be careful here. The strings that are being compared here around this pipe is not just this one, but in this case we have one set of parentheses, so the match is going to be these two words, including the space. Unlike over here when we matched hello and then we matched a space and there, in this case it's going to match either hello or hi there. Clear? Okay. Let's just skip this one. Quantifiers. Here's the second very important parts of the regular expressions, special characters. We have the asterisk, which will match any number of occurrences of a pattern. If you just, the quantifiers usually go after the regular expression character we're looking for. So you placed one of these, let's say after a digit. This is a number 1, by the way, followed by a digit, and then here's the quantifier. In this case it's a star, so any number of occurrence. So we can have, that means 0 also, right? 0 or more occurrence of the pattern. Plus, the quantifier plus has to have at least 1 or more. The question mark is 0 or 1. If you put the number inside of these braces, then it's exactly that many occurrences, or you can have a range of occurrences between these two numbers. So here's a string which contains 11000, and we're looking for a 1, and we're going to match a 1 right here. And now we want to follow that with another digit, and we don't care which it is, a 0 or 1 or whatever, 0 to 9 basically. And we're asking for 0 or more. And after that we have to have another 1. So is this going to work? Is this going to find the match? Is $1 going to give us a result here? Let's see. And yes, it found 1 and 1. And why is that? Is because it found a 1, and there is a 1 at the end, and it found the occurrence where this was actually in the case of the quantifier being 0 instead of more digits in between those two 1s. Make sense? Here we're looking for a 1 followed by at least 1 digit this time, right? This is 1 or more, and followed by another 1. So clearly it's not going to find anything. Now our code says if it finds it, it's gonna find the pattern, else it will not have found it. So it's a little more clear for us to recognize. And it has not found this pattern right here. This one is going to look for 0 or 1 digit in between, so obviously it will find it, right? It found it. Very good. Number 11. Greediness. Interesting occurrence here. What this means is the following. We're going to be using the string hello space there period nothing here period space continued with there could be something here. So you notice there's a lot of these types of occurrences in this sense here. So we're trying to find something starting with capital N. Okay, we have one right here. Then we're looking for any character except a return statement, a return character, right? And we're looking for any character but 0 or more. And then it has, after that, it has to find here. And it also has to, after the here, we must find a period. So we might think that the N is fine, then any character here until we find here. And yes, this one is followed by a period. So you would think we have a match right here, and this is true. But because Perl, regular expression, is greedy by default, that means regular expression is not going to be happy finding this one. It's going to keep looking, and it found another here, but there's no period afterwards, so it's going to keep on going. And it finds another here with a period, so actually it's going to give us this entire match right here. Let's take a look. So here we are. Found, capital N, nothing here, not satisfied with this one. Keep on going until the end. This is greediness. So how do we fix that problem? Then we can use this quantifier, the question mark, and note that unfortunately we have characters with different meanings depending on where they are. So this is the second time that we find the question mark, right? The question mark can be 0 or 1, but if it's placed in a different area, such as after another quantifier such as the star, now the question mark by itself over here now has a different meaning, and it means no greediness here. Just stop at the first indication of here after so many characters after the N. So now we're looking for capital N, and then we're going to look at any number of characters, but at the first instance of here and a period we need to stop. So we're going to say print found in this case. And here's another example here. This is another quantifier here. Now again, the caret has two meanings, but when it's placed inside of the square brackets, it means exclude the following character, and this can be looked as one character. This is the / and period. So we're looking for a period, but we're excluding the period, so any here which has a period afterwards is not a match. So we're going to look at the result for that, and here's the explanation. The caret for exclusion, what follows must not be matched. So now found nothing, and it stopped right here. Now this one is nothing here there, so it found the here without a period afterwards, right? So that's that example. Next, assertions. So now there's several other characters we need to learn. Slash U makes the next letter uppercase. Slash L makes the next letter lowercase. And then we have capital U and capital L makes all following letters upper and lowercase until it finds another assertion here, the slash capital E. And here's this other meaning of the caret besides the exclusion inside of the inside of this inside the brackets. Normally, the caret and slash capital A matches only at the beginning of a string, and that there's a slight difference, as we'll see later, between these two in different cases. Similarly, you have the dollar sign, which has very much the same meaning but the opposite, which is to match at the end of a string, and we can also use slash Z. B matches a word boundary, and capital B matches a non-word boundary. And we're going to use the same string, the same example here, and we're going to say print found the first word from the $1. And how we're going to do this? Well, we start with a caret, and we follow that by a word boundary, followed by at least one character, including underscores, and as many as we need until it finds another word boundary, which can be the beginning of a word or the end of a word. So that's in essence going to give us the very first word, because it has to be at the very beginning of the string because of the caret right here. And yes, it is. Hello. That's the first word. Now we're going to look for the last word in the string. This time we're looking for a word boundary followed by at least one character, but any number of them until it comes to another word boundary. Now, and this one is going to be also followed by a period in this case, and we don't want any period in the middle of this sentence here. We want to make sure the period is the very last character in the string. So we follow that with a dollar sign. And again, the dollar sign has several meanings, but when you find it in this place right here in the regular expression, it usually will be at the end. Then that means that is the meaning of the dollar sign in that case. And here's the last word, including the period in the very last position in the string. This one, what does it say? If string contains a word boundary followed by any letter and followed by a non-word boundary, well, that could be a period, couldn't it? But it also has to be at the very end, so it will probably match the period. The very last word, same thing as before, found here. Same thing. Next example. We're going to substitute this time. It looks like that last the last here with a period, and then we're going to substitute it with an uppercase. And notice that we have because we have the parentheses in the substitution placement of this regular expression, we can take advantage of the $1. So we're simply putting the string $1 and we're putting the /u in front to capitalize the first letter of whatever it found right here. So what we're doing is printing. String is now, and we're going to print string, and we're going to notice that string now has a capital letter in front of here. But of course, when we print just $1, is going to have the original string that it has matched, correct? So here's the string, and yes indeed, here has been capitalized, and this is the original match string. So same string, characters are turned off. Okay, so there's another way. If you have some complicated lettering that include perhaps periods and other things that you don't want to necessarily protect them all, then just use capital Q. That will turn off expression, regular expression, and until it finds a capital E. So we can ignore that one. Back references. Okay, here's a very interesting example. It looks a little complicated. It's looking for a word character followed by 0 or more non-word characters, and you notice there's parentheses around this one, so we want to remember this character. We want to remember the next character. There's 4 characters here that we want to find that may or may not be separated by non-characters such as spaces. And here we encounter some numbers, 4, 3, 2, backwards, you notice, and we're doing this globally. So these are very similar to the $sign numbers, but they don't have a $sign. The difference here is that we are using these back references inside of the regular expression. Okay, so there's a difference between these variables which are used outside of the regular expressions, or in a substitute, if you remember, after the second set of forward slashes. But we cannot use $sign variables inside of a regular expression. It's only after the regular expression has been evaluated, then the data is stored here. However, the first match inside of a regular expression can be recalled with this variable 1. So you notice that. So let's go and talk about this exercise here quickly. Use values that were previously matched with variables 1, 2, 3, and 4. The following finds a palindrome, which is a string that has the same letters backwards as forwards. In the case below, the palindrome is E moto me. Okay, if you're looking at this string here, a bit longer, the moto means something. So we're looking at E, M-O-T, and now the 4th letter is repeated backwards, and then O, we don't worry about the space here, the M matches this one, and the E matches the E. So this is a palindrome of 8 characters, and this is what this particular expression will discover. Okay, so to review, we're going to be looking, starting at the beginning of this sentence. The regular expression is going to begin there with a word character, A. Then it's going to look for a non-word 0 or more, and yes, we have a space. That counts as a non-word. And in the meantime, as soon as this is matched, of course, then that value is saved in 1. The next value is going to be a B. The next one is going to be an I, and this one is going to be a T, which is now going to be saved in number 4. And the next letter is supposed to be whatever was stored in 4, which was a T, and there will be no match right there. The regular expression is going to fall through. So the regular expression is going to start again with the next letter and try to find a motor there. And finally, it's going to get to this E as 1, 2, 3, 4, and 4 is going to match, and 3 is going to match, and 1 is going to match, and so forth, or 2 and 1. And this will work. The other interesting function here is the position function, which gives you the last position where the regular expression stopped. This is useful because sometimes you want to search through a sentence, and then you want to pick up exactly where it left off and continue with a new regular expression command. So you can use position to get you started. Very good. Let's run that. And the position is 25, which will put you exactly on the last letter of the match. And notice that we couldn't print the palindrome because these, if we want to print the palindrome itself that we have found, then we have to put a set of parentheses around the entire regular expression, in which case the first letter that we're looking for is not going to become a number 5, 4, 3, 2, correct? Now we can go ahead and print number 1. And here's the moto. Not very clean. It still has these spaces, right? So what we're going to do is clean that up using a typical substitution command here. We're going to look for a space, one space, and we're going to replace it with nothing, but we're going to do this globally. So it's going to keep going and clean out all the spaces out of your string. Good trick. Comes in handy now and then. And here's the palindrome. Here's a useful example. Here's a sentence which may be typical in some places where there's no capitalization. So here's a very interesting code to fix this problem. Okay, we're going to use a substitution string, which is going to look for several things. You can see this is it looks pretty bad at first look, but we're going to break it down. First, note the parentheses. We have a set of parentheses here that's going to gather all that information. This one is just for a pipe, which is simply an OR situation between these two choices, right? So let's take a look. Here we have the square brackets. So we're saying first, let's start with either a period or an exclamation mark or a question mark, right? Which makes sense. Anything following one of these needs to be capitalized. Here's the example of the question mark, and here's example of the period. But beyond that, and this is one or the other, and this is what? This is the beginning of a string, right? So if it's the first letter in the string, then this also needs to be a match. So here we are matching the two possibilities in front of anything that could cause an uppercase letter. Next, we want to know what follows that condition. In this case, it could be a space or more, or no space at all, as in the case of the Y. So this is taking care of that, and we want to remember that. Okay, we want to remember the entire condition, which is going to cause a capital letter. And on the capital letter, on what? On the next letter, which would be A to Z, is if it is lowercase letters, right? This is, so we're looking for one lowercase letter that follows that condition. So we have 1, 2, 3 parentheses. So this is actually the one that's going to be important also. you know about the 1, right? The 1 is going to be that condition, including the space, and then 3 is going to be the letter itself. So now we are into the substitution clause here, and we're substituting what we have found by 1, which is the same thing that we just came across, either the beginning or perhaps an exclamation mark and this. But we're going to follow whatever we found here by 3, which is this character that was found right here, but we're simply going to make it uppercase. That's it, and we're going to do this globally. I hope this makes sense, otherwise I guess you'll have to listen to the video a couple times. Make sure you understand this fully. This is a great example. And yes, everything's capitalized. The A, all done, no. Not sure what this is about. We're printing the content of these after the string, and interestingly nothing showed up. More modifiers. We have an X that allow comments inside of regular expression, very important. You can use an I, which will match without case sensitivity. M to skip on multiple lines, and when you do this, then you can then we separate the meaning of these two. This will match, these guys here will match the beginning and the end of each line, but these will now match the beginning and the end of the entire string. So be aware of that. Now here's how you use this, particularly the comment. You see, when X modifies the expression, then you can break up your expression into multiple lines and have comments. So it makes it, as you know, these regular expressions get pretty hard to understand, so it's very nice to be able to put comments. Here's pretty simple. We don't even need a comment, but for example's sake, this is going to be a substitute, right? Then we're going to look for talking, which is going to be here. This is another way to say a space, by the way, using the ASCII character. So we're looking for talking, we're looking for a space, and then we're looking for dog, followed by a period, and we're going to replace it with what? Not very complicated, but that's going to be the example. Let's just continue. This is getting long. Data input, of course, this is what regular expression is so useful. This might be somebody giving you this data through the web with a bunch of garbage in it. So what you can do is use your substitute command, look for all spaces, by the way, and get rid of those. And then print not the val name if name, now this is does not contain at the very beginning in other words, the first character of the string here, because of this caret here, has to be a word, and it has to be at least one, and it has to have as many words as possible until the very end. If this is not true, then it's not a valid name. Let's continue, and here's the last example, and hopefully this you will understand this one also. The main thing, so here we're trying to recognize a valid phone number. It's not very comprehensive. We can improve on that a lot, but let's look at what is going to at least match. First of all, something new here, the question mark followed by a colon inside of a parenthesis tells regular expression to not consider this parenthesis as its regular meaning, which is to remember it. Sometimes we need to parenthesize blocks without having that information go into $1, $2, and so forth. So this is the code to have regex ignore this. So we're looking for a 1 in case somebody puts the 1 in front of the number, followed by no space or several spaces, followed by potentially one of these, but not necessarily, because we say 0 or 1, right? And that would be followed by more spaces, possibly, and the whole thing here is 0 or 1, so somebody could put a 1 and a dash, or not, and it still count as a valid number, right? But whatever it is, this will be ignored. If we match one of those 1 and a possible dash, we're going to ignore it. This is what it says: optional 1 or 1. Optional, because of this. Next is start the alternate, and here we are looking for a parenthesis. So it looks like that one is required, followed by, wait a minute, no, it could be found, but you notice we're not remembering it. We don't care about this one. It's not in the parentheses at all. This one is in a set of parentheses, and we're looking for a digit and exactly 3 of them. And then we are looking for a right paren. Now this is, notice, also an OR situation because of the pipe. So it looks like we could have either those 3 digits surrounded by parentheses or not. There we go. Because of the pipe right here. And this is the end of this block, followed by an optional dash. So this is a dash or a space, actually one or the other, right? And we can have 0 or 1 of those. That's not very, I suppose we could improve on that one. Followed by another 3 digits, and we're going to remember that in this, I believe that's our second one at this point. And again, followed by either a dash or a space. This is another way to write the same thing, and we can have 0 or 1 of those. And finally, we're going to capture the final 4 digits, and the 4 digits have to be at the end, and right, end of line, those 4 digits have to be at the end. So this is not as flexible as it could be. Like if we had a space at the end of that, our match would not work, right? Because we're looking for 4 digits at the very end, and nothing between the last digit right here and the end of the string. But this can be improved. This is a good beginning, right? A good beginning. This is how you can use regular expression to clearly define whether it's a phone number or not. And then you're going to rewrite the phone number based on what you found. You got your area code. You notice that we have an OR situation here again. So we're going to print 1 or 2 depending on which one they've given us. Meaning they've given us something with parentheses around it or not. Whichever has data in it, we're going to print this right here. Followed by a space, a dash, a space, and the 3 digits, a space, a dash, and so forth. So this is it. Let's go and give this one a run, and it will be the end. And this case, it's 510 area code without parentheses. Interesting. I thought that this had parentheses around it. Well, let's see. Oh yes, but remember we did not save the parentheses in this case. Yes, it did match the parentheses, but we only saved the one without the parentheses. So this is why we have this result. Very good. I'm going to end it right here. Thank you very much. There's only a couple more things down below. You can go ahead and look at those. Several other back references. Thank you very much. Take care.